Good evening. This is to demonstrate parts for Swenco, which are components for safety shoes. And the major purpose is not so much to demonstrate the machine, I think that can be seen on other videos, but to show you the results in the specific parts and what the capacity is. We have two different types of material. We have a pre-coated material and we have a galvannealed material. We ran a couple of parts up front to determine how fast we can go. I do not have a specific feed rate for you, and I will demonstrate why this is not really relevant, but we are getting a very good result on the burr side. We have not run the parts on the non-burr side. One way to determine is how many parts you can run is simply to determine how many parts you could put side by side on the machine comfortably and quickly. And the question is if you can even load them as quick as what the capacity of the machine would be. And I calculated the capacity, and I think it far exceeds by a factor of 5 to 6 your annual volume of 1 million parts. As you can see, we can put a total of 1, 2, 3, 4, 5, 6, 7, 8 parts side by side with a generous spacing in between. Then what you would do is you turn the machine on and you time how long it would take for the part to disappear from where the tip is just reaching the it's just disappearing underneath the hood, and then the tail also disappears. And as you will see, this time is about approximately 6 seconds. We are turning the belt on and we're turning the conveyor belt on. I have the conveyor belt sitting at 7. We are grinding at a very light tension of 2, and the material thickness I entered at 1.2 below the material. So anyway, I apologize, but actually I just ran out of memory, so the camera stopped midstream. This is the part that came out. If we can recap, and you can see here maybe on the picture in the light, the white edge, which is the radius then of the part. We have a pretty good radius. I will send this to you and you can evaluate. Of course, we could either grind a little bit harder, which I really don't want to, or we could grind a little bit slower. To recap this, the part disappeared in about 6 seconds, so theoretically you could run 10 parts, a total of 8 wide, which would be, a total of 7 wide, which would be theoretically 70 parts a minute, which would translate into 4,200 parts per hour. Of course, you could not load 4,200 parts, but in theory, 4,200 parts in 2,000 working hours in a given year would then translate into 8.4 million parts. Now, I don't want to give anybody the impression that you should run 8.4 million parts through this machine, but 1 million would not be an issue at all. So next up, what I'm going to do, and this is going to be a little bit difficult in terms of on the camera, I am going to take this stack of parts here that I have in my left hand, and I'm going to start up the machine again the way we had it before. Same settings, 2 at 1.2, and we are just going to time how fast it takes basically to load these parts. Then I'm going to put the camera right here, and so that you can see point the parts are going to start to drop in the back already. So we're going to run around the back. Here we go. The first one drops. And you get an impression basically how fast they can run. Obviously you see, even if I hurry as much as I can't lay them totally tight end to end, which would give you the maximum capacity. But from the timing in the video, you can see what that would do for your part. I'm going to keep these here in case you want to see some different results after I return these for you. And now I'm going to run a couple of these laminated ones. And these laminated ones, let me check real quick, also have the burr on the side where you have the little the engraving. So I'm going to run that parallel. I'm going to see what that does. There we go. Coming out. On these parts we may have to work a little bit harder. You can see that we are not removing the coating. We have a little bit of a grain on top of it, but it's actually not looking bad. I am going to increase the 2.1 to 2.7, and I'm going to reduce my speed just slightly to 6. It could be that these parts are a little bit thinner than the galvanneal parts. Take it longer, and I'll give you the time, basically the throughput time for what it takes for this part. And now we have some temperature in the part, and actually the edge, hard on the camera to see, the edge looks pretty good. No sharpness left in the edge. I am not sure that you want to deburr the other side also, because I feel no sharpness in the other side. What I will do is I will run all your parts, or some of your parts on both sides and some of your parts only on one side, and then you can decide. In terms of capacity, I believe that you have ample time to do both sides if you want at 1 million. Thank you very much.